In electrical engineering, sawtooth waves are common in signal processing and power electronics. Unlike a steady DC current, these waves ramp up linearly. To understand their power delivery, we must calculate their average value over a full cycle. We substitute our function into the average value formula. Because the peak current and the period are constants for a given wave, we can move them outside the integral sign to simplify our calculation. The integral of t is t squared over 2. We evaluate this at the upper limit t and the lower limit 0. Since evaluating at 0 results in 0, we only focus on the upper limit term. Now we substitute our result back into the constant expression. We have t squared in the numerator from our integration and t squared in the denominator from our initial setup. These terms cancel each other out perfectly. Let's apply this. If you have a sawtooth current with a peak of 10 amperes, the average value is simply 10 divided by 2, which equals 5 amperes. The period length does not change this ratio. Even if the frequency changes, the relationship holds. For a 50 milliamp per peak signal, the average current is 25 milliamperes. The calculation remains consistent regardless of the time scale of the period. This visual comparison confirms our calculus. The area under one cycle of the sawtooth wave is exactly equal to the area of a rectangle with a height of half the peak current and a width of 1 period. It is important to remember that different shapes have different constants. While a sawtooth is 0.5 times the peak, other shapes like sine waves use different divisors derived from their specific integration paths. If your sawtooth wave is riding on a DC offset, you simply add that offset to our calculated average. The calculus we performed handles the alternating component, while the offset shifts the entire average value upward. To summarize, define the linear function, integrate it over 1 period, and evaluate the limits. For any standard sawtooth wave starting at 0, the average current is always half the peak current. Let's test your understanding. If a sawtooth current reaches a peak of 18 amperes, what is its average value over 1 cycle? Think about the ratio we just derived. The correct answer is 9 amperes. By dividing the peak current by 2, we find the average value. Thank you for following this lesson on waveform analysis. Generated by Vision Solve AI.